Okay, Bernoulli distribution variance. From the syllabus, we need to know the mean p, which we did last video. This is the variance p, 1 minus p. Looks simple enough, doesn't it? Let's see how it works. So, from your formula sheet under binomial distribution, and we know Bernoulli is a very special binomial distribution. The variance of a binomial distribution is NP, bracket 1 minus P. And here, clearly, Bernoulli is a special situation where n equals 1 in the binomial situation. So that n just disappears to become my P, 1 minus P. Sort of can be that easy, but how does that work? So, variance. We've done our variance revision and we know that the variance is this thing here. Mu is this expected value of x. So here I've just got a success in a Bernoulli trial is P, isn't it? And clearly, because all of these sum to 1, that must be P minus 1. In grade 11, we would call that Q, wouldn't we? But it's definitely P minus 1. So we're going to for our expected value, we're going to multiply down. So what's 0 times P minus 1 and 1 times P, and then we're going to add across to get P. We did that last video. So mu equals just P. The other thing that we're going to do is we're going to do this sum of x squared. Let's just do that. What 0 squared is 0 and 1 squared is 1. So this is going to be hard. Let's multiply down. 0 times p minus 1 is 0 and 1 times p is p. So our expected value of x squared becomes p. Okay. So in this rule here, well, they're the same rule, aren't they? Let's go the variance of x in a Bernoulli situation, because this is Bernoulli. We've got e of x squared, which is p, minus mu squared, and mu was p squared. So let's just factor out the p. Oh, that's a shock, because that's what we set up here. The variance of x in a Bernoulli distribution is p multiplied by 1 minus p. So, there you go. That's evidence that it works. Is that still clear as mud? What does that look like in a question? How am I going to do this in the test? Determine the variance of a Bernoulli distribution where p equals 0.3. Let's just go the hard way to show that we know what we're doing. Variance of x will be e of x squared minus mu squared. Let's just go jam it in here. Let's just do e of x first. So p goes in here, so 0.3, and 1 minus p, or q, goes in there. E of x, so we're going to multiply down 0 times 0.7 plus 1 times 0.3. So the expected value in this situation is 0.3. Oh my gosh, that's a shock. Let's squeeze in e of x squared. So that's 0 squared times 0.7 plus 1 squared times 0.3 equals 0.3. So e of x squared is 0.3. Mu is 0.3, and we've got to square it. Okay, so let's factor the 0.3 out. That is 0.3 times 0.7, 0.21. Do we need to do all of that in the test? Not in an external exam? Probably not. They can't make us do that. If we can validate that it's a Bernoulli situation, we can just go straight to, oh my gosh, I can't rub all of that out. Let's just do it in red so you can see it. So we're going to go 0.3, 0.7, Bernoulli equals P, 1 minus P equals 0.21. Can't stop us doing that. If a hair growth potion has a likelihood of 0.6, let's just go, okay, 0.6 is for success, 0.4, that is 1 minus P, isn't it? Yeah. So let's go n equals 1, therefore this binomial is a Bernoulli. So I'm nearly okay if you just go PQ, because Q is 1 minus P, isn't it? .24. So not rocket science. Ideally you'd understand how it works and be able to apply it in different contexts. Get to some practice.